Hey everyone, welcome to an impromptu ElmLive. Gonna take it easy today and just build a nice little SVG logo and do it in a way that we can get the benefit of Elm. So I see a few people are tuning in. Welcome. So just have a nice relaxing time and see what we can get done. And I will be doing a longer stream tomorrow again at the normal time, 11:30 Pacific, 6:30 UTC. But for today, we're just going to have nice, relaxing time making an SVG logo. So let's see. Oh yeah, so you may be familiar, Elm users, with the Elm logo, and a lot of different projects have started using the idea of a tangram and making different shapes and logos out of tangrams. So I'm going to be doing that today. So if you have been wanting to make a tangram logo for your own project, Elm related or not, this will be the thing for you. All right, so I'm going to make a new Git repository. And I think on my last stream, someone pointed me to this project that's actually called ElmLive. I've been calling my stream ElmLive with no dash, but there's a GitHub project called Elm-Live, which is a development server that does live reloading. So I want to try giving that a shot today. So let's see. Yeah, so you just install this locally and you're good to go. I'm going to do npm install elm-live. Good evening, Crits Creek. Hope you're having a good weekend. And while that's installing, I'm going to go ahead and look up sizes of all the tangram pieces. That'll be good for reference. See. Well, that's in like Japanese or something. Ah, here we go. Here's a good reference. Okay, so our npm finished installing. I think our next step is to start our basic Elm project. So I'm just going to run elm make, have it create our elm package.json, and then meanwhile start our main.elm file and make a main. And then we should be able to start up this ElmLive server. I'm going to run it straight out of my node modules folder because it's not on my path. And we just tell it the Elm file starts up the server, and if I load that up over here, got this. And now what this does for us that I haven't had set up before is if I change this, as soon as I save, it's going to refresh the page and automatically update. So cool. We've got that working. I'm also going to bring up a reference of the Elm logo. Well, I guess they don't have it on the web page anymore. Elm logo. There we go. Cool. So let's go ahead and get started. So here's how I'm thinking about this. I want to make it easy to be able to reposition and potentially recolor the pieces in the logo. So we're gonna, I think, have each of the shapes defined independently, and then we're gonna try to make some utility functions that'll make it easy for us to stick the pieces together and build whatever tangram shape we want. Once we get the main logo in, we can try making a couple other logos. So, to start out with, I'm going to use SVG for this. So we need to install that package. Let me kill the server for a moment. Do Elm package install ElmLang/SVG. Then I'm going to start up the live reload server again. Refresh the page. Okay, so basic SVG example is going to look like this. We'll say svg.svg. Actually, I'm just going to expose everything in there because we're going to be using a lot from that package. So our root element will be an SVG element, and we usually start with two things. We're going to have a view box, which comes from the svg.attributes package. And this takes a string that gives the top left corner and the width and height of the coordinate space in which we're going to be drawing. So I'll try to explain that a little better once we have something up on the screen. So I'm going to do -5, -5 as the corner and a width and height of 10. So this is going to give us a virtual coordinate space that we can draw on, and the visible space in that coordinate system will be from -5, -5 to 5, 5 in the other corner. And then in here, let's just put a circle for the moment. And the basic thing we need for a circle is the radius. I'm going to make a radius of 2 units. And here is our drawing. Great. So, let's see. So what's next? Oh yeah, we might as well show that you can also set colors with the fill attribute. So, I think we're ready to get going. So, the first thing we want to make is a triangle. Let's start with this gray triangle on the left. And so, okay, so a tangram set has, let's check the pieces. Got 2 large triangles, 2 small triangles, a square, a rhombus, is that what this is called? Or a parallelogram, and a medium triangle. So let's start with the 2 large triangles. And the way I'm going to define a triangle is by specifying the length of the small side. So the small triangles are of size 1, the large triangles are of size 2, and the medium triangle is of size square root of 2. So let's start with the triangle of size 2. Well, that's kind of silly. Why don't we start with the triangle of size 1? Just make the triangle. So what is a triangle? A triangle is going to be a polygon, an SVG attribute, or an SVG element. And the attribute for polygon is, we say, points. And we give comma, well, we basically give an array of points, but they're grouped into 2. So a common thing to do is put commas and then separate the individual points with spaces, but you can actually use spaces and commas interchangeably in SVG. It's a fun world of parsing in SVG. So let's see. I want to just make a basic triangle shape that has the first point is the tip. Then let's go up, or well, okay. So let's have this. Well, I can't draw easily. you'll see as soon as I get this out. So I'm imagining this is going to be this corner that connects the two short legs, and that's going to be in the top left corner. And then I'm going to have the triangle kind of rotated a bit. So let me draw this and you can see. So the second point is going to be 1, 0, and the third point is going to be 0, 1. Let's draw that. Okay, and let's get rid of this circle. Great. So there's my first triangle. Now, what I'd like to do is be able to make triangles of different sizes and of different colors. So the color's the easy part. Let's do that first. I'm going to make a parameter called color. And what's our first triangle? Our first one is kind of a weird shade of gray. I guess we can actually grab the correct color with digital color meter. Let's see, can I play this as X? There we go. So this is 5A6378. 5A6378. All right. Why don't we grab all these colors while we're here? Actually, I'm going to do this. Colors equals a record, which has gray. And we're also going to have green, orange, and blue. The blue is 5FB4CA. 5F4CA. Orange is EFA5. And the green is 83C833. 3C833. Okay. And this is just going to be colors.gray now. All right. Looking good. Okay. The next thing I want to parameterize is the size of the triangle. So we said the triangles differ based on the length of their short legs, is how I want to model them. So I want this triangle to be of size 2. Give it the size. And okay, so before we do that, I think we need to refactor this a bit so that we're actually using numbers here. So let's see. I think the way I want to do this is we can maybe define the points as tuples. That. Then we can convert these to strings. Actually, first we need to flatten these. Let's do an anonymous function that takes the tuples and turns them into lists, and then actually we can concat them all together. So this is going to take each tuple, turn it into a list, and what the concat part of this does is then flatten the list. So now we'll get a list of just all these integers. Then we can convert them to strings. And then we can join them with commas. And then we can stick them in the points attribute. Let's see, what error do I have? I need to import string.join. All right, so it looks like that's all the same still. Now we're in a good position to extract the size. So rather than 1, we're going to use the size. And there we go. The triangle's bigger. Let's show small triangle just for comparison. Triangle of size 1 is colors.orange. And there we go. Looks good. I am going to shrink the viewport up just a little bit. Maybe make this 3. There we go. So that's a little better for us looking at this. All right. So what's next? So we can create all these shapes. We created the triangle. That's most of our shapes. And the square and the parallelogram, I think, will be pretty easy. But before we get to doing those, the next thing we're going to need is to be able to rotate these triangles. So let's figure out how to do that. So our triangle currently is basically producing an SVG element. Actually, let's put the types on here. So this takes an int and a string, which is the color, and gives back an SVG. An SVG of type message, which is the same as HTML, can produce messages. Okay, so the problem with producing SVG is that we can't manipulate it. Well, I guess that's not true. There actually are attributes in SVG where we could take this SVG element we've created, wrap it in a group, and then rotate or scale or transform that group. However, thinking ahead, what I want to be able to do is define a triangle, and then when I define the next triangle, I want to be able to snap it to certain points on the first triangle. So to be able to do that, we are going to be we're going to need to have access to those points. And if we have an SVG, we can't access the points inside anymore. So instead, here's what I want to do. Instead of having triangle return SVG, I'm going to have it return a list of points. So why don't we even define point as a class, as a type alias, excuse me, is a float. And then we're going to define a new function called draw, which is going to take a list of points, and it'll also take a color. Let's put the color first, and then produce our SVG there. So, color, points. I can't call it actually points because there's a thing in the SVG package which is called that. And there we go. All right. So Crits Creek in the chat is suggesting that I should turn on the inline errors in the editor, and I think I agree for today. I have been trying to do in my past streams to not have those on in the editor, just so people can learn how to find the errors if they don't have that set up. But I think for today, that'll be good. Let's see. So where is... There we go. Language, whoops. Language Elm. Enable autocomplete. No, I thought it was in a package called ElmLinter. Oh, do I not even have it installed? Let's try installing it. Linter Elm make. There we go. My buddy Michael. Sounds like a great guy. All right. So while that's installing, let's take a look at what our errors are. So we changed these. So basically here is the list of points. So that's now going to be called PS. All triangle returns is that list. Triangle doesn't need the color anymore. And then the rest of this is all moving to the draw function. All right, and now, complaining, the triangle only takes one argument. So now, for both of these, we have to do that. And what's wrong here? Oh, it thinks these are all ints. Oh, okay. So this should actually take a float for the size. We're going to have irrational numbers for the size of the medium triangle. All right, that refactoring is successful. These warnings, okay, main is a program never. Or, oh no, main is just an SVG message. And colors, I don't really want to put an annotation on colors. I am just going to turn off the warnings for today. Usually use them in practice. Maybe having this record for colors is not the greatest idea, but all right. So now our triangle produces a list of points. A list of points is something that I believe we can rotate using some simple math. Let's look up how to do it. Rotate 2D point. Rotating a point around another point. Should just be sine and cosine. Yeah, here we go. This is not the simplest version of it. Oh, here we go. Great. This is what we need. Okay, so here's what I want to do. I want to take this large triangle and define a new operation on it called rotate. And we want to rotate it 45 degrees. And then we need to define rotate. I'm going to take a float for the angle and a list of points and give back a modified list of points. All right. So all this needs to do is list.map over the points and rotate each one of them. So let's use a let in here. And the new point is going to be based on this formula. This is going to be, well, first of all, we need the angle in radians. In Elm, we do that with the degrees function, which converts degrees into radians. Then I guess we may as well do this, let's see, in here. So we're going to take the cosine of radians, let's just call it rad, and multiply by the point x and the other point. Okay, so that's kind of, here's the simple version I was looking for. So the new x is the old x times cosine plus the old y times the sine. Then the new y is negative sine actually, I'm just going to say it this way. Sine times negative x plus cosine radian y. Cosine times y, sine times x. Okay. All right, and yeah, there we go. Our triangle rotated. So let's check this out, and we rotate by 0, back where we started. If we rotate by 5 degrees, turns a little bit up, and goes a little farther. Okay, whoops, 45. Okay, I think that looks good. So, our actual Elm logo, going to have it rotated another 180 from that. There we go. That's in place. And let's draw our second triangle. Triangle, it's of size 2. We're going to rotate, I'm not sure how much, and then we're going to draw it with blue. All right, so I think we need to rotate -45. Damn, got it. While we're here, why don't we add this border? So I'm just going to do that in the draw function so that all shapes get this. And we're just going to add a stroke of white. And I think it's a little large because our coordinate system is quite small. So we'll put a stroke width of 0.1. Yeah, that does. Yeah, great. All right. So I guess we can put this other orange triangle in place. We just need to rotate it by 45 plus 90. Yep, there we go. All right, this is shaping up. Okay, so what's next? We need to make this parallelogram. Let's do that. Hope I spelled that right. And check that in Google. Parallelogram, nailed it. First time speller. All right, and then we're gonna take that and we're gonna draw it in green, I think it was. So let's define this parallelogram. This is just gonna be a list of points. There's only one size of it that we need for our purposes. And let's check it out. So this, let's say this on the left is our origin. So then the first point, okay, so we'll start with 0, 0, 0, 0. Then let's go this way. Our second point is at 1, 0. Then our third point here is 1, 2 is 2 over and 1 up. So that's at 2, -1. And our last point is at 1, -1. Hey, there we go. Great. So now let's rotate it into the right position, the right orientation. So I think it needs to rotate -45 degrees. Let me see with that. Yeah, okay. So that's the right orientation. Now we just need to move it. And rather than having to hard code the movements or the positioning, what I want to do is try to do something kind of clever here and be able to snap the this shape to the corner of another shape. So what I'd like to do is something like this. Snap to and snap it to a different shape. So actually let's take our triangle, call this big 1, and put that in a let statement. So the big triangle number 1 is that. We'd like to snap to it, but we need to kind of define which points in the shape we want to snap to. So in this case, I want to take the first point, or let's say the 0th point. So we'll have point 0, 1, 2, 3. So point 0 in the parallelogram, we want to snap it to this point in the triangle. I'm not sure which point that is. I think it's the second point, which would be point number 1. Actually, that's confusing. Let's just call the points 1, 2, and 3. Forget 0 indexing. Let's go hardcore. We can handle off by 1 errors, no problem. Okay, so here's basically what I'd like to write and say this basically will mean snap the first point of the parallelogram to the second point of the big triangle. And I think that'll be a pretty nice way to express coordinated shapes. So let's define snap to. This is going to take an int, and it's going to take a point. Okay. So actually what we want to do is say snap point number 1 here to second point of this. We're going to need a couple things. We're going to need 2 takes a list of points. That's our shape. And it takes an integer, which is which point. And it gives back one of those points. Then snap to is going to take an integer first. That's which point in this shape. The point to snap to. And then finally the list of points, which is the shape that we're going to be modifying. Point number and snap target. And this is the points that I've just been calling PS here. Okay. So let's write this function first. I think it's a little easier. Or I'm speculating that it'll be easier. So here, we're going to have a list of points, and we're going to have a point number. And we want to return a point. So I think we can use list functions for this. We are going to say list.drop, and we will drop however many we're looking for. Or so if we pass 1 in here, we want the very first point. So I think we want to drop point number -1. So if we pass 1, we'll drop nothing. Then we're going to take the head of the list. So let's see. We're going to start with the whole list. So this might be YZ. Then we're going to drop however many. So if we're passing 1, we'll drop the first one so that we get at the, we pass the number 2. We want to get the second one, which is Y. So first we'll drop the first element, everything up to that. And we'll get the head after that. And then head is going to return a maybe. So we need to say maybe.withDefault, and we'll just return 0, 0 if there isn't a matching point in here. Then snap. Let's write this. So actually, I think we're going to kind of need to do the same thing. We need to find the relevant point. Let's do that. And I think we'll do a case statement. See how that goes. So we'll find the relevant point, and if we get one, call it the pivot point. So if we get a pivot point, we basically want to translate all the points in the list. So we might need to define a couple more operations. I think we want to to move a point, let's see. If we have a shape, say we wanted to snap this corner to the corner of the gray one. Okay, so what we want to do to every point in this shape is we want to first subtract the pivot point. So that would basically move the shape to the origin. And then we want to add the coordinate of the destination point. Okay, I think I have in my head how this is going to work. So we want to subtract. The pivot point. Then we want to add the snap target point. And we'll need to define these. And then if we didn't actually find a pivot point, we'll just return the same points. All right, so then let's define sub and add. So subtract, we're going to take a point and a list of points and return back the list of points that'll all be translated by that amount. And this is going to be essentially the same as adding negative x, negative y. So let's just define this in terms of add. And then we'll define add, which will basically have the same type signature. Let's call this dx and dy. And we'll have our points. We're going to list.map over the points. And for each point, you're going to return x plus dx and y plus dy. All right. So what's wrong here? Type annotation is wrong. Oh, I didn't specify the type of the return value. There we go. Hey, look at that. The parallelogram has moved to the corner. So I think this might be working. I'm just going to play with this number here. So if we snap to point 1 of the gray triangle, okay, that's the first point. This is point 2. And we can also snap to point 3. Yeah, great. So that's where we wanted it. All right, so let's finish this guy off. Next, we need, let's do our medium triangle. So this is going to be a triangle. The size is going to be the square root of 2. And then I think we're going to need to rotate probably. And then we draw it in blue. Yeah, okay, so we need to rotate it negative 90 degrees, I think. Yep, and then we want to snap it. I don't know which point yet. We want to snap it to the parallelogram. Let me grab this. I'll just call it par, I guess. We've already used the function name parallelogram. Okay, so we've snapped to one corner. We'll find the correct corner of the parallelogram. Nope, I bet it's number 4. Yeah, there we go. Then let's find the correct corner of the triangle. There we go. All right, I like where this is going. All right, what's next? We need a square. I don't think we've defined that yet. So we're going to have a square. We will probably need to rotate it. And then we will draw that in, what color was it? Green. So let's define square and spell it correctly as well. All right, rotate, triangle, parallelogram. Okay, square. This one should be easy. We're going to have 0, 0, 1, 0, 1, 1, and 0, 1. All right, there's our square. Rotate this bad boy. So 45. There we go, perfect. And finally, our last triangle is a small triangle of size 1. Probably need to rotate, and this is colors.orange. And we're going to rotate it 45 degrees. Then we are going to snap its corner to, let's see, I guess we need to pull out another one of these. Make this triangle be big 2. Big 2 equals that. And then we're going to snap this one to big 2. Not sure which point. Okay, not the first point. There we go. That's the right point for the big triangle. Then we want just the third point for the orange triangle. Yes. There we go. Okay. This feels like a commit point if I ever felt a commit point. So let's get in there. Tangram logo. Yes, GG. Okay, so we need our get ignore. Echo node modules. Get ignore. And we also need our Elm status, or excuse me, the Elm stuff. So yeah, what I want to do next is make another tangram shape with us, and we can maybe time that one. Elm stuff. And okay, status. What do we have here? Oh, we don't need index.html. Right. Yeah, we can have Elm SVG logo design be a new speedrun game. I want to see TaskBot play this game. All right. So we've got the Elm logo. Right, so let me push this up to GitHub. I made a repo for this already, which is linked in the video, but there's no code up there yet. Here is what I want. Run this. All right, so now the code is up. So if you want to follow along and make your own tangram while I do the one I want to make, then go ahead and grab it. And let's see. I always forget how to find this site. I usually end up searching for Tangram camera. And this is the one I'm going to make. And this is from a web page that has like thousands of tangram shapes listed here. So if there's any kind of tangram thing you want to make, this is a really cool site to find it. However, you do have to, it doesn't give you the solution. So yeah, I happened to solve this one earlier. Let me just solve it again real quick. Oops. And then this is the one that I'm going to make, because I want a nice logo for ElmLive. And let's see. And this one goes up here. So yeah, if you want to follow along in a minute, go quickly find your own tangram shape that you want to make and clone the repository. can I rotate this? There we go. This one works. This way. Okay, so that's the one I'm gonna make. So, before we start that, I guess we should just extract this. So what we want to do is rename this file to be called pieces. And then we want to duplicate this. So not duplicate the whole folder, just duplicate pieces. It will be called Elm logo. Okay, so Elm logo is just going to have the main and the colors. And everything else we're going to move to pieces. Import it. Then in pieces, we're going to delete the colors and the main, leave all the shapes. All right, so let's kill the reload server. Instead, have it build elmlogo.elm. That means to rename this module. Then Elm logo. Okay, we also have to import SVG. Okay. So we do need to import this stuff in SVG. Grab that stuff. And pieces. Oh, okay. So then we have conflicts with some of the SVG attributes. Okay, so I'm just going to expose what I'm using. There we go. Okay. So now we've extracted this into a separate thing. And then we can just take that and build our own shape. I'm going to add that, git commit-m, extract pieces.elm, push that up, and let's make our camera. So I'm going to start by duplicating Elm logo. Call this camera.elm. And let's start with our first piece, our big triangle number 1. That is rotated incorrectly. So let's see, can I get this as a reference visible at the same time? There we go. All right, so our first triangle should be rotated 90 degrees. Great. Then our second triangle should be rotated 180 degrees. No. Negative 90 degrees. All right, and then we want to snap this one to the other triangle. To that corner and this corner. That is not what I was expecting. Oh, there we go. Okay, I just wasn't sure what corner was which. Okay, then let's take our small triangle next. So our first small triangle So that we want to snap to the top corner. Of the blue triangle, which, well, I guess it's the corner of either triangle. Yeah, so that corner. Oh, we didn't rotate it properly first. We need to rotate this 180. There we go. And we want a different corner here. Got it. Yeah, quickly suggesting we should add debugging to render the corner numbers or something like that. Sounds good. I feel like that could be a big time sink, but it doesn't sound like a good idea. Okay, I'm just adjusting the view bounds so this is more in frame. All right, so next we've got our square. Pick this up here. And that is not going to be rotated at all, but we are going to snap one of its corners to, I guess, the second triangle we already have points for. Actually, that corner I happen to know is the first point. So let's snap third point of the square. Bam, got it. And then finally, well, not finally, almost finally, the penultimate shape. All right, so then we have our other small triangle, is this one. We're not going to rotate it. Okay, great. And then we're going to snap it to the first point of the big triangle. Huh. My reload is taking 2 saves right now for some reason. Great. Then, okay. So now our parallelogram, and we've kind of got a problem here because these don't snap directly to any shape. So let's get it close and then see what we need to add here. So let's do the triangle first, actually. Triangle. Whoa, what's it doing way over there? Oh, because we still have this parallelogram. Okay. So we'll try rotating by 0. And now we want to rotate it by, I think, 135. Nope, close. 225. There we go. Then we want to snap to the first big triangle. And let's snap it to that point. Great. Want to snap the first point of this one. Okay, that's close. And actually, why don't we stick the parallelogram in for the moment. That off. Okay, so that needs to be rotated, right? Or does it need to be flipped? I think it actually needs to be flipped because I don't think we can rotate it to the right orientation the way it is. Yeah, we need to flip that. So I think we need a new operation called flip. Let's go add that to points. And I think it's going to be very similar to add. Except it won't take a pivot point. All it's going to do is negate the x. Keep the y. I think that's what we want. Ooh, whoa. What happened? The reload server jumped back to the wrong file. Oh, do I have multiple servers running at once or something? Let's restart this thing. Oh, I started editing. Oh, that's weird. I was editing the camera file this whole time, but the reload server was loading the Elm logo file. I'm not quite sure how that thing works. Oh, maybe it's confused because the module names are different. Okay, so flip is ambiguous. Camera, so I guess we can say pieces.flip. Okay, there we go. And then we're going to snap the parallelogram to the medium triangle. So let's pull the medium triangle out first. And then this is going to snap to the medium triangle. And we want to snap to the first point there. And we want to snap, I think, the third point of this. There we go. Okay. Now all we need to do is shift the medium triangle down. And I guess we already have something to do that. We can just add. So the X is not going to change. And the Y is going to go down by how much? Okay, so let's calculate this actually. So the base of the parallelogram, check our pieces reference. The base of the parallelogram is 1 unit. And the short side of the large triangle is 2 units. So we should just be able to shift this down by half. Bam. There we go. Cool. Well, I guess that's it for today. I am super happy with this. And yeah, this is the new logo for ElmLive, or I guess I can mess with the colors here a bit. And I guess I should also mention, you may have seen this from following me on Twitter, but we are organizing an event called Elm Bridge, which also has a nice logo. We'll probably redo our logo with this in SVG. Elm Bridge is following in the tradition of Rails Bridge, which is a great organization around the world now. It started in San Francisco to get and promote women, largely, is what Rails Bridge is focused on. Get more women into tech by giving them free workshops and a welcoming environment. So we're going to be running the first Elm Bridge along those same lines in a few weeks. It's already sold out, unfortunately, but we're also going to be open sourcing the curriculum and helping other cities and other communities run similar events in the future if they want to, and help making sure they get set up for success if they are interested in doing that. So yeah, here's our Tangram logo for Elm Bridge, a nice bridge. So I guess go wild. Maybe this will unleash a lot more nice looking Tangram logos in the future. I am looking forward to seeing them. So have a great evening, night, morning, or whatever it is for you. And if you're tuning in tomorrow, I will see you then.